Okay, so what do you think the retinal nerve fiber layer thickness map tells you? Jimmy, top right here, what do you think this tells you?
Can't tell from pointing.
You can't tell where I'm pointing. Okay, let's use the pen. What do you think this tells you?
It tells me the retinal nerve fiber layer right around the optic nerve
It's not very thick.
is not very thick.
Good. Same interpretation as GDX. Thickness map just tells you qualitatively what kind of nerve fiber layer you're seeing. If you look at right eye versus left eye, do you see differences?
Yes.
Yeah, one's a lot worse than the other, right? Okay. So right eye, left eye differences are visible. Look at the signal strength, 6 out of 10. Is that acceptable? Six out of 10 signal, is that good? Signal strength? Sure, acceptable. You look at the deviation map, right here, and you see big chunks of problem. That's not good, right? Like the GDX measures nerve fiber layer between those gray circles, OCT measures it right on the red circle. Just the diameter is different, that's all. So, the T-snip map, which is right here, is obtained from on the circle measurement. The rest of it is very, very similar again. You have average thickness, you have quadrants in various quadrants, you have clock hour thicknesses. Clock hour thicknesses tend to vary a lot. Average values tend to be very stable in measurement. So I wouldn't jump on just one isolated clock hour being abnormal. However, if you do see one isolated clock hour abnormal, you can go back to the nerve head and see if you are seeing a notch there. You may have missed it the first time, but you might go back and be able to find a notch. Okay, so it certainly helps to obtain good data and cross-check with what your findings were. You see green, yellow, and red, and the nerve fiber layer is following. It's almost down to the red, essentially telling you that this is a very high chance of being abnormal. But of course, even inferior average thickness tells you that, the same story. Inferior average is also color-coded like the other quadrants, but if you ever want to know, when it starts getting close to 93, there's a chance that it is getting towards glaucoma. So inferior average, and it's low, then that's one of the most diagnostic parameters of diagnosing glaucoma. You can write the same story, does not follow isn't rule and stuff like that based on the nerve fiber layer measurements in this region. You go to page number 10, you see the same device has a different output, which is more recent output. So even though the signal strength is great, look at 8 of 10, you look at this picture, fundus image, and you see these breaks in blood vessel. Can you see that? Can you see a little break in blood vessel there? See how this blood vessel is chopped off? Okay, that's because of eye movement. This disc, disc looks really funny, but it's not really. It's actually eye movement right in the middle of the disc as the scanning was occurring. Okay, so this person has not kept their eye steady, and there's lots of eye movement artifacts. You need to write that down. Even though the quality is good, there's too much eye movement, you may consider repeating the test for this patient. The rest of the parameters, average retinal nerve fiber layer thickness, retinal nerve fiber layer symmetry, rim area, disc area, they're all color-coded. Disc area, most of the time, if they are outside normal limits, in terms of, outside normal ranges, they are in gray. Any parameter that is in gray, that means the range or something is outside the measurement variables obtained in the normative database. It does not mean abnormal necessarily, it just means that the machine does not know whether it's normal or abnormal. That's when you have a box shaded gray. So you have all these parameters that are very self-explanatory. You have neuroretinal rim thickness, essentially is this thickness right there. Let me shade that area. take this area, this shaded area, and plot in XY axis, you get this plot right here, your retinal rim thickness. Again, showing you that if it falls in the green, that's good. Falls in the red, it's not very good. Nerve fiber layer thickness, right eye and left eye is compared to each other, and the more similar they are, the better it is. This is the horizontal tomogram and the vertical tomogram. What are they? Well, a horizontal tomogram is one line scan along the horizontal cut of your OCT, and that's right here. A vertical tomogram is a vertical cut in your OCT, which is right there. These are not very helpful for glaucoma per se. You don't make any major diagnosis from this, other than the fact that it sort of gives you an idea how deep the cup is, how wide the cup is. But once in a while, you find artifacts of imaging telling you what's going on. So if you look right carefully, this red line goes all the way to the border and the bottom of the cup. You see the red line there? That tells you that the disc is margin, and that's how deep the cup is. But sometimes you find imaging artifacts are going to be flagged. For example, can you see this particular scan? Look on your computers, how this red line does not follow all the way to the bottom of the cup. It's sort of in between, hanging there. Or if you see in this location, in the second, right here, you see how this little tuft of blood vessel is being assumed to be part of the disc, and that's not part of the disc. See how this little bottom blood vessel is assumed to be the bottom of the cup, and it's not the bottom of the cup. And these are imaging artifacts or algorithm failures. And you need to write those down, saying that imaging artifacts visible, algorithm failures, cup volume may not be as indicated by the machine. So this machine, this scan for this patient, left eye, the cup volume is actually underestimated on the basis of these errors that are visible right here. The rest is color-coded, so it gives you an idea of what is abnormal, what is normal, and it should be quite easy for you to analyze. So go ahead and do interpretation report of one OCT.